A frightening exposure made by the James Webb telescope uncovered what it all the reserves of being city lights in space. Tracked down 7 trillion miles from Earth, this pivotal finding has ignited interest in the chance of extraterrestrial life. The telescope, focused in on Proxima Centauri B, the closest exoplanet to Earth, uncovering abnormal brilliant lights transmitting from it. What could be the reason for these city lights on Proxima Centauri B? Could this show the presence of life beyond on our planet? Join us as we dig into how the James Webb Telescope distinguished these phenomenal things in space. For a long time, specialists and individuals at large have expected and investigated the chance of life beyond our solar system. Any proof seen to back up the space dream has been welcomed earnestly. As of late, standard researchers were stunned when proof of living things existing in space was seen by the James Webb Space Telescope while investigating space and transmitting data back to Earth. The James Webb Space Telescope saw odd city lights shimmering from the exoplanet Proxima Centauri B. These lights, as their name suggested, seem to enlighten a distant city. The chance of an outsider city existing on the star has left scientists in stunning disbelief. They are confounded, since this could be the presence they've all been waiting for. If this winds up being true, as many believe it could, it implies that intelligent living things are building civilizations unknown to what humans know. In space, we are simply beginning to think that it is looking into the city lights viewed as 7 trillion miles from Earth. NASA engineers can't help but wonder how long these lights have been shining in space, waiting for humankind to develop the technology necessary to detect them. David Kipping, a space expert from Columbia University, describes the Proxima B exoplanet where the city lights were found as captivating. He said, "So because the star system closest to us has fluctuated warming patterns that aren't like those of other planets, the ordinary rocky planets are known to absorb daylight and radiate infrared radiation, but not for this exoplanet. Its infrared nature is very different from that of its host star Proxima Centauri. This hints at a critical observation by the James Webb Space Telescope, JWST, which is capable of recognizing infrared frequencies. The distinctive heat signature Proxima B will play a key role in revealing the planet's atmosphere icy secrets. Thanks to the latest technology in infrared imaging, scientists intend to use the JWST to reveal the secrets of its atmosphere. They also hope to use the telescope to assess the potential for life on this exoplanet. The James Webb Telescope has infrared sensitivity that can examine what occurs on Proxima Centauri B's nighttime side, catching even the slightest light emissions in the immense darkness. This is usually a challenge for space telescopes, but not for the JWST, which can detect even the smallest light emissions from space. It is the perfect tool to check if the rumors about city lights on Proxima's nighttime side are true. Any artificial lighting in the universe can be detected by the telescope as long as it falls within a frequency band multiple times less than starlight. Proxima B has an intriguing connection between its stellar components and surface features. The daytime side of the exoplanet contains countless solar panels that absorb the brilliant energy from the star. Its ghostly edge also reflects incoming light beams at the same time. When Proxima B completes its orbit around its host star Proxima Centauri, it experiences constant periods like those on Earth. During the day, it experiences high solar heat, while at night it cools off. The planet is known to have fluctuating temperatures still determined by its composition. For example, if there's no atmosphere on Proxima B, the difference between its day and night periods will be very quick and extreme. Without the regulating influence of atmospheric gases, the temperature on the day side will be extremely hot, and the night side will plunge into cold darkness. The level of temperature variation is a significant subject for space experts to unravel a deeper understanding of Proxima's atmosphere with the JWST. Unmatched infrared imaging abilities will enable efficient analysis of the planet's thermal emissions to provide valuable information about its atmospheric properties. Inquisitively, the orbit of the James Webb Space Telescope around Earth aligns with Proxima B's orbital period, allowing for intensive observations of its day and night cycles. Within 11.2 Earth days, since Proxima B does indeed have an atmosphere, the subsequent step will be to evaluate its atmospheric science to determine whether it can support life. Key indicators of something happening below the surface include the presence of gases like oxygen, water vapor, and methane. If these elements could be found in the atmosphere, it would suggest habitable conditions. The process of determining this requires specialists to be cautious as they capture and analyze light beams passing through the planet's atmosphere. This is a challenging task to undertake, even with the JWST exceptional capabilities for describing planetary climates. While powerful, the James Webb Space Telescope doesn't have absolute capacities and can only peer at a few of the closest plausible worlds to conduct serious atmosphere assessment. Space experts are now looking towards ground-based observatories like the extremely large telescope ELT, which is set to begin operations in 2028. The ELT is designed to test the atmospheric composition of distant exoplanets and will provide data that offers in-depth insights into their habitability. NASA specialists and the public eagerly anticipate the development of future space telescopes like these. Until then, the James Webb Space Telescope remains a vital tool in our mission to uncover the mysteries of far-off exoplanets. Despite its current limitations, the JWST has the potential to provide significant insights that could disrupt how we understand exoplanetary exploration. Specialists have set an objective for future space telescopes to reduce the amount of brilliant light coming from a planet's host star, allowing space experts to better see the light reflected from the planet itself. They intend to do this by using internal masks or large external satellites shaped like an umbrella, much like using your hand to block out sunlight altogether to see an object more clearly. Reducing the harsh brightness from a host star will enable future telescopes to focus on faint traces of light from a distant exoplanet, allowing for a more profound examination of its atmosphere and the possibility of supporting life. However, this comes with its own challenges, as scientists must differentiate between gases produced by life and those from geological processes like volcanic activity. Space experts are not giving up on understanding the characteristics of exoplanets to better detect signs of life beneath the surface and distinguish them from false positives. The Webb telescope represents a glimpse of scientific advancements in exoplanet research, offering a preview of the surprising discoveries we have yet to make as we expand our understanding and exploration of the universe. Further, we are better situated to grasp the complex functions of the universe and our various roles within it. In the wake of searching through all the planets in space, scientists have yet to find one that harbors life. Despite decades of looking through space for signs of life, the mission continues. Are we alone in the universe? For centuries, humans have wondered whether they are the only ones in existence. This age-old yearning still persists today. Even now, researchers have the James Webb Telescope in space, attempting to detect alien civilizations tucked away among us while studying EOS planetary bodies for signs of life. At the same time, a popular theory has emerged recently suggesting that some aliens could truly be out there in the stars just waiting for humankind to find them. To address this question too, American astronomers Jill Tarter and Thomas Pearson started a project called the Search for Extraterrestrial Intelligence SETI in 1984, known as the SEI Foundation. It is a non-profit venture that aims to filter through cosmic transmitters to identify radio signals from space. The reason for focusing on radio signals is their ability to travel vast distances without getting scattered or absorbed like other types of radiation. Due to this property, radio transmissions are more likely to be detected by the 42 radio telescopes that make up the Allen Telescope Array, situated in the outpouring hills of California. Although the SEI Foundation has constantly monitored transmissions of these radio signals produced by alien life, no such signals have been detected for more than 30 years. Jill Tarter remains confident about the odds of success, expressing a desire to empower Earthlings everywhere to become active participants in the quest for extraterrestrial intelligence. All of this went on until recent reports from NASA demonstrated that the James Webb Space Telescope spotted city lights from a planet close to Earth. The JWST is the giant card played by humankind to gain a better grasp of the vast mysteries in space. Launched in December 2021, it is known as the best infrared imaging telescope made by humankind, equipped with the most advanced optical technology available today. The James Webb Space Telescope can look beyond the cover of cosmic dust to uncover the secrets of the universe. Its primary mission is to explore the universe in search of the first galaxies and stars that were formed billions of years ago. The telescope is designed with some of the most refined optical technology in this present era, inspired by James E. Webb, a visionary NASA administrator who was a key advocate for space exploration and the Apollo moon landing programs. At its core, the James Webb Space Telescope is built with a unique array of instruments, all working together to provide unrivaled views of the universe. This includes a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument, and a fine guidance sensor that allows it to maintain its precise position in space. The giant mirror of the James Webb Space Telescope, composed of 18 hexagonal segments, has been carefully designed to capture faint light from the earliest galaxies in the universe. It is designed to operate at very low temperatures, allowing it to detect weak heat signals transmitted by distant objects. Since its launch, the James Webb Space Telescope has delivered on its promise by unveiling the most distant and oldest galaxies ever. Its powerful instruments have provided new insights into the formation of stars, the evolution of galaxies, and the creation of exoplanets. The discovery of city lights on Proxima Centauri B is a crucial finding that adds to the growing body of evidence suggesting the presence of life beyond our solar system, while further investigation is needed to confirm the nature of these lights. The James Webb Space Telescope has undoubtedly opened a new chapter in our mission to understand the universe and our place within it. Launched in December 2021, the James Webb Space Telescope is equipped with cutting-edge infrared imaging technology that allows it to appear through cosmic dust and reveal the secrets of the universe. Its primary mission is to observe the formation of the first galaxies and stars billions of years ago. However, its capabilities extend far beyond that. The discovery of city lights on Proxima and to be the closest exoplanet to Earth is a remarkable achievement that raises intriguing questions about the potential for intelligent life beyond our solar system. The bright lights seen on Proxima Centauri B suggest the presence of an advanced civilization capable of creating artificial lighting. This discovery has significant implications for how we understand the universe and the possibility of life beyond Earth. Researchers are now focusing on the nature and origin of these lights, investigating various hypotheses to explain this phenomenon. One of the primary goals of the James Webb Space Telescope is to study the atmospheric composition of exoplanets by examining the thermal emissions and chemical signatures of Proxima B. Scientists hope to determine if the planet has the necessary conditions to support life. The presence of gases such as oxygen, water, vapor, and methane would be strong indicators of a habitable atmosphere. The James Webb Telescope's infrared sensitivity makes it an ideal tool for this investigation. Its ability to detect faint light signals in the vast darkness allows it to observe the thermal emissions from Proxima Centauri B and gather crucial data about its atmospheric properties. The telescope's alignment with the planet's orbital period enables thorough observations of both its day and night cycles within a relatively short period. Understanding the temperature variations of Proxima Centauri B is essential for determining its atmospheric composition. If the planet has no atmosphere, the temperature difference between its day and night sides would be extreme, like a dark body. However, if it has an atmosphere, the temperature variations would be moderated, indicating the presence of atmospheric gases and possibly liquid water. The discovery of potential city lights on Proxima Centauri has reignited scientific curiosity and prompted deeper investigation into the possibility of extraterrestrial life. Proxima Centauri B, located in the habitable zone of its star system, has long been a target for researchers searching for signs of life beyond Earth. While the notion of city lights may initially sound fantastical, the detection of unusual light emissions by the James Webb Space Telescope JWST has made it a serious point of discussion within the scientific community. Astronomers are exploring various theories to explain these lights. One possibility is that they are caused by some form of artificial lighting, suggesting the presence of an intelligent civilization. However, natural phenomena such as volcanic activity or bioluminescent organisms could also explain these unusual emissions. The JWST advanced technology allows it to detect even the faintest signals, making it an ideal tool to investigate these anomalies. Scientists are now keenly focused on understanding the atmosphere of Proxima Centauri B. The presence of an atmosphere would significantly reduce the temperature fluctuations between day and night, providing a more stable environment that could potentially life forms